Okay, the partial fraction, I will do it gradually, means that the first few questions you see that is very basic. Okay, so I may skip certain small steps. Okay, if not, I cannot cover everything. So let's take a look at this one. So this one, you must understand. Okay, let's take a look at the denominator. Okay, for what is partial fraction, you must understand what is partial fraction. In AMath, you all do a lot of like two fractions combined into a single fraction, right? So in partial fraction means what? It means from a single fraction, you need to U-turn to give the two or three separate fractions. This is what it means. Okay, AMath is like doing the reverse way. Okay, so let's check the denominator. Okay, I know we have three cases. Case one is when it's linear. Linear means x plus 1, whereby the highest power is to the power of 1. So if it's linear, we know that this one gives birth to a over x plus 1. And then after that, this 2x minus 1 is also linear, so it gives birth to b over 2x minus 1. Okay, then you ask yourself, oh, I want to combine this into a single fraction. What do I do? A must multiply with 2x minus 1. B must multiply with x plus 1. Then my denominator, of course, is x plus 1 and 2x minus 1. Then by comparing coefficient, you say, oh, so 5 minus x, which is the top one, is equals to this, which is A, 2x minus 1, and B, x plus 1. Okay, so actually there's two methods. This is actually identity. It means the left-hand side is exactly the same as the right-hand side. So you either can open up the rainbow, everything here, and then compare coefficient. That is one method. Okay, second method is you sub suitable values to make certain things disappear, and then you solve the unknown A and B. Okay, I personally don't like comparing coefficient unless it's very simple to rainbow lah. This one for this case is still quite easy to rainbow. But if those whereby it involve two brackets or even got square, I will not use comparing coefficient, because when with all the so many alphabet and when you rainbow, the chance of mistake is so high. So it's not advisable to do comparing coefficient. For this case, I will show you comparing coefficient. Okay, so I will just rainbow it out. So I have 2ax minus a plus bx plus b. This one you don't shift it. Then after that, this one, if I'm going to take out x, you have 2a plus b and then minus a plus b. So you know that by comparing, you will see that, oh, so 2a plus b is equals to -1. This is my equation 1. And then this one is the constant. So minus a plus b is equals to 5. So this is my equation 2, right? Then you Okay, I'm skipping the solving simultaneous. Of course, if I solve so many questions of simultaneous, I think tomorrow already. So you by right, then you will solve your A. A will be 2. I believe it's -2. So your A is -2. And then your B is 3. Then once you're done with this one, you say, oh, so therefore, this one, 5 minus x, this one will be equals to this. Okay? This is how you do the partial fraction. This is just warm up. Both situation is linear, the case 1. Okay, let's take a look at this question 2. So this one, let's analyze. Okay, this one, x squared plus 1. This is quadratic. So whenever you see quadratic, but first of all, you need to ask yourself, can I factorize the quadratic expression or not? X squared plus 1 cannot factorize. So that means you will apply case 2. No, case 3. Case 3 is a quadratic. Case 3 means that this will give birth to ax plus b. Okay? Okay? That's a case 3. Then this x minus 2 is linear. So it applies is case 1. So I put plus c over x minus 2. Okay? So now let's see. If I'm going to combine to a single fraction, of course, I have x squared plus 1 and x minus 2 as the denominator. This one, ax plus b must rainbow with x minus 2. This c must rainbow with x squared plus 1. Okay, this is how you combine to a single fraction. Then after you will say, oh, so 5x squared will be equals to this one. So it will be ax plus b, x minus 2 plus c, x squared plus 1. Okay. Then how are you going to solve this? Okay, of course, you can use the comparing coefficient, but let's try out. Okay, if I'm going to sub in x equals to 2, do you agree this one becomes 0? And when this one becomes 0, 0 times this thing, everything becomes 0. So I only left with this side one. So in this situation, I can solve my C. So 5, 2 square equals 0. I don't need to write already. So this will be C, 2 square plus 1. So I end up having 25C. So it becomes C equals to 4. And see, I solved my C. So once I'm done with my C, I left with this one, right? Then you analyze. Aha. Do you see that AX? Do you agree that if I sub X equals to 0, A times 0 will A disappear, right? Yes. So I can happily sub X equals to 0 as well as my C equals to 4. I have 5 0 square equals to A times 0. That means I will have 0 plus B. I have 0 minus 2 plus 4. 0 square plus 1. And then I am having just 0. This is B and negative 2. So it's B minus 2. This one is 1 times 4 plus 4. So I end up having 2B equals to 4. My B equals to 2. So you see, I solved both B and C. I only left with one unknown, which is A. So what do? When you only left with one unknown, you can sub any X value you want. Okay, so now let's go to sub X equals to 1, right? So I'm going to write it over here. Okay, use red color. So it will be sub X equals to 1. Okay, of course, as well as your B equals to 2, as well as your C equals to 4. So now let's type it in. So 5, 1 square equals to A1 plus 2. And then after that, we have 1 minus 2 plus 4. And then we have X squared means 1 square plus 1. So I end up having 5 equals to A plus 2. And this one is negative 1. And this will be equals to 8. So I have 5 equals to negative A minus 2 plus 8. So I have minus A plus 6 and 5. So bring A, this one bring over, becomes 6 minus 5. So my A is equals to 1. So now I have my A, my B, and my C. Okay, so when we have done that, then we see that's the answer. That's why we will say, oh, so therefore, 5x squared over 1 plus x squared, x minus 2 is equals to my ax plus b, right? So my A was 1, my B is 2. So ax means x plus 2 over x squared plus 1. And my C was 4, so plus 4 over x minus 2. So it's the same exactly like mine, but that's me the other direction. So this is the question for number 2. Okay? Okay, this one. So they say one of them, x, the one is linear, so this one will give birth to A over x. This is a quadratic. And when it's a quadratic, you have to factorize it. Okay, when we factorize it, let's say 1, 1, and 2. So I have, see, I cannot factorize. Okay, you give me funny number, it's imaginary. Okay, when it's imaginary, what do? That means you cannot factorize, you will have to apply the case tree. So in this case, it becomes plus bx plus c over x squared plus x plus 2. Okay, so in this case, it will become my A must rainbow with x squared plus x plus 2 plus bx plus c and with x over x squared plus x plus 2. So now let's compare this one and this one. So I have 3x squared plus 2 equals to ax squared plus x plus 2 plus bx plus c and x. So in this case, because you see you don't have a lot of bracket, right? So this one you can only use compare coefficient. So let's rainbow it out. So this one will become ax squared plus ax plus 2a plus bx squared plus cx. So 3x squared plus 2, this one combine x squared will become a and b. My x will have a plus c, and then I have a 2a. So by comparing, I have 2a, which is a constant, is equals to 2. This one very straightforward. I can straight away solve my a, right? And then after that, I have my, let's see, this one is x squared, right? X squared is this one. So a plus b is equals to 3. And because you already solved your a, so 1 plus b equals to 3, b equals to 2. Again, I solve this. Next is A plus C. So my A plus C, don't panic, don't see any X, right? It's fine. It means that A plus C is 0. So since I already have my A is 1, so 1 plus C equals to 0, so C equals to -1. So we are done with the ABC. So once we are done with it, then you just sub it in, and then you become, see this one, my A, 1. So that's why it's 1 over X. My B is 2. So that's why it's 2X. The C is -1, so you put it in this format. So you will write this equals to this, and you are done with this part. So this question tells me what? First is quadratic. And when quadratic, you cannot factorize into 2 brackets, you don't panic. It simply means that you apply straight away case 3. You put bx plus c. You understand? Then you solve as per normal. And this question, because there's no bracket, you cannot use a substitutable value. You have to use comparing coefficient. Simply just rainbow everything to the left-hand side, compare with the left. Okay? You will form equation and then you solve the unknown. So let's decide which case to use, right? 4x squared minus 1, this is quadratic. Okay, quadratic, some students straight away apply the case 3. But like I mentioned, every time quadratic, you have to ask yourself whether can you factorize or not. So in this situation, common mistake is student put what? They put, oh, so ax plus b over 4x squared minus 1. This one linear, they say, oh, so c over 2x plus 1. This is the common one that student put. Okay, but the actual one is what? You will be surprised to see, okay? First, my 4x squared minus 1, I can factorize to become 2x plus 1 and 2x minus 1, right? Factorize it, it becomes this way. So it means that, oh, so this one, if I rewrite, it's supposed to be 2x over 2x plus 1, 2x minus 1, and there's a 2x plus 1 here. Then do you notice there's 2x plus 1? So actually this one become what? This one become 2x over 2x minus 1, but I have a repeated 2x plus 1. So in this question, end up I apply case 1 and case 2, not case 1 and case 3. You see that? So this one should be give birth to a over 2x minus 1. And this one, the repeated, which is a case 2, it will give birth to 2 fractions. It will give birth to b over 2x plus 1. And it will give birth to c over 2x plus 1 squared. Yeah. So I'll keep it up. So c over 2x plus 1 squared. So you see, it come up 3 fractions, okay? So this one is under the case 1, which give birth to 1. This one is under case 2, which it will give birth to 2. Okay, so now again, we combine into a single fraction. So this a, because this one is 2x minus 1 only. So I need to multiply with 2x plus 1 squared. This one, b, will have to multiply with 2x minus 1 as well as 2x plus 1. This c will just need to multiply with 2x minus 1. The whole thing over 2x minus 1, 2x plus 1 squared. Then you will have, oh, so this one equals to this whole thing. So you will say 2x equals to a 2x plus 1 squared plus b 2x minus 1, 2x plus 1, and then plus c 2x minus 1. Then you say, wow, so long, how to solve? Okay, this one I will not advise you to use expansion and comparing coefficient, because the right hand side, I think I rainbow, I think I will faint. So you use suitable value. So let's see. Look at this one. If I sub in half, do you agree that this whole thing, everything disappear? I only left with an a, right? So I will sub in x equals to half. So I will have 2 half equals to a 2 half plus 1. This one 0 already, this one 0. I don't have to write already. So I just do 1, 1, 2, 2, 1 plus 1, 2. 2 square is 4. So it will be 4a. Oh, I think just now I have this error. Okay, so 4a equals to 1. So in the end, my a is equals to 1/4. See? 1/4. And when you write 1/4, you put it in this way. 1 at the numerator, 4 at the denominator. Then after that, once we are solved with a, we do as this one. Now look at the 2x plus 1. So now I'm going to sub in x is equals to -half. Because when I sub in this disappear and this disappear. So then after that, we have 2 negative half equals to disappear, disappear. So I only left with this one equals to C 2 negative half minus 1. So I have minus 1, minus 1, minus 2. So I have C minus 2. So I have C equals to minus 1 over minus 2. So my C is equals to half. So let's see, my C is this one. See? Plus 1 square. This one. But why is it that mine is, oh yeah, half. Okay, so positive half. Do you see that? 1 over 2. Yeah. Then you left with a C. Sorry, you left with a B. So you see, A done, C done, you only left with one unknown B, right? So if only unknown B, you can suck any X value. So of course, I no longer want to suck in fraction, right? Let's suck in X equals to 0. Lor. So what you can do is suck X equals to 0. Take note, this is the number 1. This one is the number 2. The number 3, then you suck in X equals to 0. Because you need to solve your A and C first. Then now it's 2, 0 equals to 1 quarter, 2, 0 plus 1 square. B is the unknown. So this one will be 2, 0 minus 1. 2, 0 plus 1. And then this one will be plus half. 2, 0 minus 1. Okay. This one I can leave it to you all to solve. So based on my answer, my B is what? My B is this one, negative 1 quarter. So when you solve, you get B equals to dot, 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 B equals to negative 1 quarter. And then you get the answer. Okay, so in this question, what you need to be careful is when you see quadratic, you need to factorize it. For this case, factorize is using the A square minus B square. And then after that, I factorize already there, I notice, oh, I end up having repeated. So I'm applying case 1 and case 2 instead of case 3 and case 1. Okay, for this question, this is sort of tricky. Okay, question 6. They say express impartial fraction. Then, you see, so far I've been doing proper fraction to you, right? But a lot of time they will come out improper fraction. So how do you confirm that they are improper? First, you need to check the degree. So let's take a look at this one. Degree means the highest power. So the degree is 3. Look at the denominator. Imagine you remember everything already. You will know that the highest degree is also 3. Okay, when the numerator degree is equal or more than the denominator, it's considered improper. Okay, 3, 3 is still improper. Common mistake is student, they say same degree, then they say it's proper, but it's not, it's improper. So when it's improper, what do you have to do? The additional step you need to do is you have to do long division. It's just like if I have 3 over 2, I need to show that this is 1.5. So you have to do long division. Okay, so what I need to do is why is my phone keep ringing? Okay, then after that, how do you do? You are supposed to do the long division, but first of all, let's rainbow this up, because if not, how are you going to do long division, right? So rainbow, I will get 4x cubed minus 2x squared plus 6x minus 3. So I'm going to do the long division, 12x cubed. Okay, take note kids. Do you notice that this one don't have x squared, don't have x? So when you're doing long division, when there is missing term, please put in plus 0x squared plus 0x, then put plus 2. It's a compulsory thing that you must put a 0. You must have a space for them. If not, it's difficult for you to do your long division. Then divide it by, okay, this one don't have missing terms, so divide by 4x cubed minus 2x squared plus 6x minus 3. So you know that you need to multiply by 3 to get this one. So this one times this one, I get this. This one times this one, I get minus 6x squared. This one times this one, I get plus 18x. This one times this one, I get minus 9. And when I subtract, please put the bracket. Okay, this is the this one easy way for you to see. So 0 minus minus 6, I know is 0 plus 6. So this one is 6x squared. 0 minus 18, so this one is minus 18x. 2 minus minus 9 means it's 2 plus 9, so it's plus 11. So that's why I will end up having, oh, so this one means it's 12x cubed plus 2 over whatever is equals to the mixed number. This is the same as saying 1 plus 1 over 2 ma. So this is the quotient. So 3 plus the remainder over, now I can write as the 2 bracket, 2x squared plus 3 as well as 2x minus 1. So when it's an improper, you got to do this additional step. Then after that, temporarily ignore this 3 first. Look at this proper fraction. And then this proper fraction will be what I have done on the above questions. Apply the case 1, case 2, case 3. So let's take 2x squared plus 3. Oh, this is a case 3. So first, of course, I write out the question first. Is equals to ax plus b over 2x squared plus 3 plus, this is the linear, which is c over 2x minus 1. Then I'll say, oh, so that means it will be ax plus b. And then after that, this one will rainbow with 2x minus 1. C will rainbow with 2x squared plus 3 over the 2 bracket. Then you'll be doing this, which is 6x squared minus 18x plus 11 equals to this ax plus b, 2x minus 1 plus c, 2x squared plus 3. Then, of course, the remaining, I leave it to you because it's exactly the same like a previous what we do. Is there any trick thing that I need to take note to tell you? Don't have. I forget my 1 bracket. So, yeah. So after that, you solve already, then you get, then the common mistakes. So then after they do this already, then they forget that they have to bring back the 3. Okay, so do you notice the answer over here? Yeah. The answer here got the 3. So it's 3, then you plus the 2 thing. Okay, so you need to bring it back. So this is for the last question 6.